All right, these are the notes over polygons. I write polygons up here on the top. What we'll cover first, a lot of four-sided polygons. Don't forget triangles are also polygons. We've been talking about them a lot. All the shapes except for circles are polygons that we've been dealing with. The first one, a parallelogram. Parallelogram usually looks something like this. There's different kinds of parallelograms, and each one of these shapes, there'll be different kinds. I'm going to draw one or two of them, but you'll need to know that just because they don't look exactly like mine, they might also be that same shape. For a parallelogram, all the properties of a parallelogram, first thing, opposite sides. Number one here, opposite sides are parallel. So this side has to be parallel to that side. This side has to be parallel to that side. That starts getting us into these angles are same side interior angles or consecutive interior angles, which must be supplementary, and we'll talk about that down here. Opposite sides are also congruent in a parallelogram. So this side has to be the same length as that side. This side has to be the same length as that side. I would draw all this on your notes so that you know all these different things are true about every single parallelogram or whatever shape it is we're dealing with. Number three, opposite angles are congruent. So this angle has to be congruent to that angle. This angle has to be congruent to that angle. Always in a parallelogram. Consecutive angles, that's like these two angles. So those two, those are the ones that are same side interior or consecutive interior angles. They have to be supplementary. They have to add up to 180 degrees. Diagonals, if I draw another one, since that one's about full, that doesn't look a whole lot, doesn't look real good, but the diagonals going from one corner to the opposite corner, then the other corner to the opposite corner, the diagonals aren't the same length because the shape's tilted, but the diagonals do bisect each other. So this point's a midpoint for both of them. So this segment is congruent to that segment. This segment, let's actually put different markings on that. Those two are congruent, and then these two segments are congruent. All the angles, so that angle, that angle, that angle, that angle of this parallelogram always must add up to 360. Just like a triangle has to, all the angles have to add up to 180. Any four-sided figure, any quadrilateral, that's a four-sided figure, quadrilateral. The sum of all the angles must always be 360 degrees. That's for any four-sided figure, so that'll work for all the four-sided figures that we talk about. Triangles always three angles always add up to 180, and a quadrilateral, the four angles always add up to 360. So that's a parallelogram. Next, a rhombus. A rhombus looks something more like this. In a rhombus, it's a parallelogram, so all those properties, I'm not going to redraw them, but all those properties that we just did on that last slide work for a rhombus also. Opposite sides are congruent, opposite sides are parallel, opposite angles are congruent, the diagonals bisect each other, so on and so on. And then it has these new properties. All four sides in a rhombus, all four sides, just like in a square, all four sides have to be congruent. The diagonals, if we draw in the diagonals, the key thing for a rhombus is the diagonals. When you draw in those diagonals, the diagonals bisect the angles. So this has to be congruent to that, which is also congruent to that and that. So all four of these are congruent. All four of these parts have to be congruent if this is a rhombus. And the diagonals form right angles. So in the middle here, all four of these angles are always going to be right angles. And where that's going to be key at is then that forms a right triangle there, forms a right triangle here, and we did all the stuff like Pythagorean's theorem, the SOHCAHTOA with the trig functions and all that stuff with those right angles or right triangles. So we could use any of that on any of those four triangles that are formed there. To prove something is a rhombus, got two things here. We're not going to do a whole lot with proving that things are a rhombus, but to be a rhombus, if it's a parallelogram and consecutive sides, so I know that they tell me that this shape's a parallelogram and that these two sides are congruent, sides are attached to each other, then it's got to be a rhombus. And the second one, if I know that it's a parallelogram and the diagonals come together, if I could draw the diagonals, and they form a right angle, then it's got to be a rhombus. And again, as I go through this, we're not going to do a whole lot with the proving stuff. We're going to deal more with the properties. A rectangle, these should be numbered here, number 1, number 2, number 3. Again, a rectangle is a parallelogram, so it's got all the properties of a parallelogram, so opposite sides are parallel, opposite sides are congruent, opposite angles are congruent. And actually in this, if it's a rectangle, not only are opposite angles congruent, but all four angles are congruent, and all four angles must be right angles. So all four of those angles must be right angles. In a rectangle, unlike in a parallelogram, if I go from this corner to that corner, and I go from this corner to that corner, those diagonals have to be the same length. The diagonals have to be congruent to each other, and that's important in a rectangle. This length is always the same as that length. With this, if that's true and it's a parallelogram, then the diagonals bisect each other, so we know that all four of these little parts of the diagonals must be congruent to each other. And again, these are the ways to prove something is a rectangle. First, you got to know it's a parallelogram, and then if it has a right angle, then it's got to be a rectangle. If the diagonals are congruent and it's a parallelogram, then it's got to be a rectangle. Properties of we already did a rhombus. Properties of a square, and again, these should be numbered. 1, 2, 3. With a square, something is a square if it's first a parallelogram, so it has all the properties of a parallelogram, has all the properties of a rectangle, and it has all the properties of a rhombus. So a square has all properties of the others. All the properties of all those three that we covered already. So in a square, opposite sides are parallel, opposite sides are congruent. Since it's a rhombus, all four sides are congruent. Since it's a rhombus, the diagonals bisect the angle. So that would mean that this is a 45-degree angle, that's a 45-degree angle. And since it's a rhombus, that has to be a right angle in there. Well, then now we have this, and that means that has to be a 45, 45, 90 triangle. And anytime you draw a square and you draw in both diagonals, if I tell you that that shape's a square and I draw in both diagonals, every one of those triangles there has to be a 45, 45, 90 triangle, and we have all those properties. So all the properties of all the other three work for a square. Any of those things that we talked about previously there work for a square. A trapezoid. Trapezoid may look like this. There's different ways a trapezoid could look, but what has to be true, and again, these should be numbered, 1, 2. In a trapezoid, you always have one pair of opposite sides parallel. They're changing things now, so it could be at least one pair, and a trapezoid falls into where a parallelogram is a trapezoid, or a trapezoid could be a parallelogram. We're not going to deal with that a whole lot, but so it's at least one pair of parallel sides now is what a lot of the definitions are saying. But the old definition is that it has exactly one pair of parallel sides. So in a trapezoid, always you're going to have that one pair of parallel sides. Angles surrounding a leg are supplementary. If these are your two parallel sides, these two sides are called legs. Sometimes the legs are the same, sometimes they aren't. We're going to talk about ones where they are the same on the next slide. but the angles surrounding those two, so that angle and that angle, got to add up to 180 degrees. This angle and this angle have to add up to 180 degrees in every trapezoid. An isosceles trapezoid, just like an isosceles triangle, an isosceles trapezoid is a trapezoid where these two sides are parallel and the two legs are congruent to each other. That's what makes it an isosceles trapezoid. And you notice if we went up here and we did this and it looked like an isosceles triangle, it's like cutting off the top part of an isosceles triangle. The properties of an isosceles trapezoid: one pair of opposite sides parallel, we talked about that. The angles surrounding the legs are supplementary, they add up to 180. So this angle and this angle add up to 180. Those two add up to 180. And these two add up to 180. Again, all these angles have to add up to 360 because that's for any four-sided figure. That works for square, rectangle, rhombus, parallelogram, whatever it is. The diagonals, or I skipped number 3, pairs of base angles are congruent. In an isosceles trapezoid, you might want to draw another one. If this is an isosceles trapezoid, then this angle has to be congruent to that angle. This angle has to be congruent to that angle. And then another property of an isosceles trapezoid is if we draw in the diagonal here and the diagonal here, notice the diagonals don't bisect each other like the other four-sided figures, but the diagonals, this whole length and that whole length, have to be congruent to each other. They have to be congruent to each other. So that's an isosceles trapezoid. A kite it's got a bunch of motion in it. I didn't realize that. In a kite looks like this. And let's draw a better one. That's a horrible one because that's going to confuse some people. Kite looks something like this. In a kite always has two pairs of disjoint sides that are congruent to each other. In other words, unlike some of the other shapes, it's the sides that are hooked to each other that are congruent there, and then the other pair of sides that are hooked to each other are congruent. A pair of opposite angles are congruent. In a kite, the pair of opposite angles that are going to be congruent are always going to be, this one is congruent to that one. It's going to be where you could separate the two pairs of congruent sides. The diagonals form right angles, so anytime you have a kite, if we have a kite, this one, and I draw in the diagonals, if I could draw a good kite, those angles in the middle there are always going to be right angles. One diagonal bisects the other. You can notice in a kite, this diagonal is probably not being bisected because this bottom section is longer than the top section, but this diagonal is being bisected. So those two parts will always be congruent to each other. And the diagonal going down this way will always bisect the angle. So this angle is congruent to that angle. This angle is congruent to that angle. Again, all the angles of the original kite, if I draw another kite, looks something like that maybe, that's a terrible kite. But this angle, this angle, this angle, and this angle all got to add up to 360. That works for any four-sided figure. The angles in a four-sided figure always have to add up to 360. For all polygons, these are formulas for all polygons, and these are very, very important. The sum of all the interior angles, and this is not just for four-sided polygons, but five-sided polygons, six-sided polygons, seven-sided, eight-sided, so on, so on, so on. Any polygon, the sum of all the interior angles. So if we got an octagon that's got 8 sides, then it's going to have 8 angles. N here stands for the number of sides. N is number of sides in the shape. So if we wanted to find the sum of all the interior angles, that means all 8 angles added up, we just plug in whatever the number of sides there is. So if it was 8, we'd plug in 8 there, and we do 8 minus 2. Well, 8 minus 2 is 6, and then you just take 6 times 180, whatever that is on your calculator. That's going to be the sum of all of the interior angles, all the angles inside the shape. Sum of the exterior angles of a polygon. An exterior angle, if I was to draw, let's say I draw this pentagon here. An exterior angle we talked about, just like with the triangle, that's an exterior angle. There'd be an exterior angle there, an exterior angle there, one there, one there. There's always going to be however many sides it has. It's going to have the same number of interior angles, the same number of exterior angles. So this one's going to have 5 exterior angles. The sum of all those angles is always 360 degrees. No matter what the shape is, whether it's 5-sided, 6-sided, 7-sided, 8-sided, the sum of all those interior angles is always 360 degrees. If we're dealing with a regular polygon, we talked about regular polygons. Regular polygons, all sides congruent, all angles congruent. If we're dealing with a regular polygon, then these two formulas work so that you could find each interior angle and each exterior angle. So if we knew that this pentagon here that I drew was regular, so that means all the sides are congruent and all the angles are congruent, then we could plug in to this formula and find what the sum of all the sides are. So 5 minus 2 times 180, that gives us 3 times 180, which is 540. That means all these interior angles add up to 540. Well, if they're all the same, all we got to do to find each one is divide by 5. And on any regular pentagon, each interior angle is always 108 degrees. So if you see a pentagon that's regular anywhere in the world, all those angles are 108 degrees. Then for each exterior angle, you just take 360 divided by the number of sides. Well, this would be 360 divided by 5, and that would give you 72. So each one of these angles outside has to be 72 degrees. We could also notice that an interior angle and an exterior angle have to add up to 180. So interior angle plus exterior angle equals 180 degrees. So that also works. Notice that this formula is a whole lot easier than this formula. So if you know an interior angle, it might be better off to find an exterior angle and go from there. Or it's always, if you get a chance to use this formula, it's going to be easier than using that longer formula. This chart just shows you the different polygons. 3-sided polygon, which of course is a triangle. 4-sided polygon, which is a quadrilateral. Remember, quadrilaterals include all of those shapes: squares, rectangles, rhombus, so on, and includes all of those. 5-sided pentagon, it gives you all the names for all these. When we get down here to the bottom, I think we wrote down this chart earlier this year, or part of this chart. When we get down here to the bottom, N number of sides polygon, anytime you have a polygon that's not on here, it's not one of these names, like if it's got 24 sides, then we just call it a 24gon. We just stick 24 in place of N right there, and that's how we name the polygon. The sum of the interior angles, I wrote them all down here. For a triangle, the three angles of a triangle always got to add up to 180. Quadrilateral, four angles of quadrilateral got to add up 360, 540, 720, so on and so on, all the way down this chart. That's just using that formula right there that I gave you on the other slide. The sum of the exterior angles, you'll notice, always 360 degrees. No matter what the shape is, the exterior angles always have to add up to 360. And these last two here is if the polygon happens to be regular, then these are the measures of each angle. If it's a regular triangle, which is an equilateral triangle, we already know that each interior angle is 60 degrees. Well, each exterior angle is going to be 120 degrees. And it works all the way down through here. We did a pentagon on the other side. Each interior angle is 108 degrees. Each exterior angle for a regular pentagon is 72. Again, these last two here only work if the shape is regular. Not every pentagon in the world has every angle 108 degrees, only if it's regular. And then down here at the bottom you have the formulas for finding each interior angle, each exterior angle if the shape happens to be regular.